find this integral, and find in terms of a the value of this integral here, where a is a constant greater than 2. Deduce the value of this integral here. So I've summarized the question. So we need to find these integrals. First one here, these are all powers, but we use the fraction rule. If you have 3 plus 4 over 9, say, we can write that as 3 ninths plus 4 ninths, using simple properties of fractions. You can split a fraction up, in other words. So we do no different to this, even though it's more complicated looking. In principle, we do precisely the same thing. So let's have a go at A then. So here, the answer then is equal to, well, it will be the integral of the first part over the x, so x cubed over x, plus the second part, of course, so I'm splitting the fraction up, 3x to the half over x dx. So let's work out what these are, first of all, in terms of powers of x. Divide your minus top take bottom, so this is x squared, plus 3 lots of, and then we've got a 1 there, so half take 1 is minus a half, so this is x to the minus 1 half, isn't it? Now we can integrate these simple powers of x. Raised by 1, divide by that number, plus 3 lots of, raised by 1, so that's a half, divide by that number, divided by a half, is the same as multiplying by 2, of course, plus k, a constant of integration. So that's last line then, x cubed over 3, plus the 2 comes up to be with the 3 to make 6, x to the half, plus k. Part B, find this integral here. So B answer is equal to, so let's do it straight away. It's going to be 6x raised to the power by 1 minus 3, divide by that number, and we're evaluating this integral between the definite limits 2 and the value of a, which is greater than 2. So now we can work this out. It's equal to, well, the 6 over 3 goes in twice, so we can simply put 2 here, and the minus can come up to the top. So it's minus 2 over x cubed, isn't it? And then top value, so it's a cubed. So that's the top value, minus the bottom value, so it's minus 2 over x cubed, but this time the value to put in is 2 cubed, isn't it? So that's what we've got. Close bracket, so that equals. So what have we got? We've got a 2 here over 8, which is a quarter, and it's a plus, so it's a quarter. And this is minus 2 over a cubed here, isn't it? So that's what we get for the integral there. Now that was B part 1. So let's have a look at B part 2. Deduce the value of this integral. So basically it's the same as above, but a is having the value, so to speak, of infinity. So here, part 2, as a tends to infinity, the 1 quarter minus 2 over a cubed will tend to, well, this will tend to infinity, be very, very large. So this number here, 2 of a very, very large number, will be very, very small. And as a quarter, take away an incredibly small number, so it's going to get closer and closer and closer to a quarter, isn't it? So as a tends to infinity then, and gets large, this becomes 0. Quarter take nothing, is just a quarter.